Take a look at this team mapping out a complex blueprint. When starting a brand new software project, the default instinct is usually right here, leaning in and asking what specific feature should be built first. Focusing on features leads teams to conflate three distinct methodologies: the prototype, the proof of concept, and the tracer bullet. Confusing these creates a deceptive problem. Teams generate code, but waste budget answering questions posing zero threat to survival. Experienced engineers step back from feature lists. Instead of asking what to build, they ask exactly what uncertainty they are trying to reduce. That reframe changes the entire development path. These three early-stage artifacts do not compete with one another. They are entirely different tools built to handle entirely different uncertainties. Selecting the right technique is a matter of identifying the biggest immediate risk to the project and deploying the specific tool engineered to test it. Choose the wrong tool and you burn capital solving a problem you don't actually have. Building early-stage artifacts without defining your primary risk first guarantees wasted engineering cycles. You end up converting your early momentum directly into technical debt. We can evaluate build options with this comparison matrix, plotting methods against user, tech, and workflow risks. We'll use an AI travel planner to test them. The prototype focuses entirely on the audience, answering a single question: can people understand and use this idea? To build a prototype for our AI travel planner, the inputs are strictly visual. A team will create wireframes or clickable UI mockups of the booking interface. The outcome here is validation of the user experience. You want to confirm that the product logic actually makes sense to a traveler before you write heavy logic. The required trade-off is permanence. Prototypes are facades with no real backend, and the assets you create rarely make it into production code. The proof of concept shifts the focus away from the audience. It asks a narrow technical question: can this specific technology actually work? The inputs for a PoC are small, isolated engineering experiments. For the travel planner, this means writing a quick script to test if an AI API can reliably parse an ambiguous prompt and return a structured itinerary. The outcome is concrete evidence. You prove that a single critical technical assumption is viable in reality. The trade-off is isolation. A PoC completely ignores user experience and system scalability. It operates entirely as a narrow test, not a complete product. Prototypes prove the market wants the interface, and PoCs prove the core technology functions. But neither approach proves you can actually build a functional, integrated system. That brings us to tracer bullet development, which completes our matrix. This method asks, can our complete workflow integrate end-to-end? The inputs here are structural. You are building a very thin but fully functional path straight through the actual production architecture. Looking at this workflow for our AI travel planner, the tracer bullet must capture a user request, send it to the AI engine, fetch data from an external weather API, log it in the database, and finally return a displayed result. The outcome is workflow certainty. You prove that disparate individual components can communicate and execute a real task together. Unlike a prototype or a PoC, a tracer bullet guarantees structural viability. It sacrifices feature richness and polished user experience to ensure the bones of the system connect. The immediate trade-off is cost. Setting up the necessary infrastructure requires a much higher initial engineering effort. Because the cost of entry is so high, you only deploy this method after basic user interest and technical feasibility are already confirmed. Tracer bullet development serves as the ultimate structural test. It mitigates the specific risk that isolated product successes will break when wired together in a production environment. These three approaches do not form a mandatory linear sequence, and they are never in competition. To map the right artifact to your scenario, you can follow a straightforward decision framework, starting with this question: what is your biggest uncertainty? Founders and designers dealing primarily with user and product risk belong on the prototype path. This path yields incredibly fast iteration cycles to help you find product-market fit. The trade-off is that you accept having zero proof your backend tech stack can actually execute the vision you just designed. Tech leads exploring new APIs or unproven backend tools face single technology risk, directing them to the PoC path. Here, the outcome is deep mathematical confidence and a core technical capability. but you accept the risk of engineering a beautifully functional back-end engine for a product that nobody actually wants to use. Systems architects carrying a project toward production face system integration risk, placing them on the tracer bullet path. This delivers total validation of the deployment pipeline and guarantees the complex integrations hold up under load. The trade-off is significant setup friction. If the core idea fails after building a tracer bullet, pivoting requires tearing down heavy infrastructure. Professional engineering requires identifying your biggest uncertainty first, then choosing the exact tool built to destroy it. Different uncertainty requires a different tool.